Okay, good afternoon, everyone. Thank you for hanging around to the Let's Talk of the day. For those of you who don't know me, my name's Peter Mckenzie. I occasionally treat at Mckenzie Wi-Fi, but you know what the saying goes, it's not the quantity, it's actually the quality that counts. So do follow me if you want to see the occasional treat. My session today is going to be about wireless LAN specification and validation, because I think the two are very keenly connected. Is it not working very well? It's my little ears keeps falling off. Let me know if it comes off again. Okay, so I'm going to talk about specification and validation. What I want to do, and we'll see whether I can do it, is I want to talk about a lot of things that you probably already know. But I'm going to talk about a lot of things you probably already know, because what I want to try and do is, I think for at least some people in the room, stop you from going in this direction and turn you around to go in another direction, if you'll allow me to do that. And so I'm going to tell you a lot of things you know, and hopefully, I'm sorry about this microphone, hopefully that will help you to maybe rethink how we do things a little bit. So, first thing on the first slide, I've just put an example specification, which an Arab specification. Some of you may have seen specifications like this before. I'm by no means condoning this as a good specification, it's just a specification. I get asked to do a lot of wireless LAN designs, and very often customers, when I meet them, they'll say, we want you to design as a wireless LAN, and we want it to meet this specification. And they'll give me something like I've put on this slide. Do you know what I want to do when that happens? I want to take that specification, rip it in two, and throw it in the trash. Why do I want to do that? Is it because I'm really arrogant and I think that because the great Peter Mckenzie hasn't written it, it must not be worth the paper it's written on? Yes, basically, yeah. Yeah, well, no, it's not quite like that. It's not quite that. It's actually because, to me, something like this has more questions which I can't answer. I'm pretty sure the person who wrote it can't answer. And I'm not even sure if I asked the person who wrote it what it means, they could even tell me that. Normally, they've maybe gone online and gone to some sort of design specification and just copied and pasted. Okay? It's also coming at the wrong stage in the design cycle from my point of view. They've asked me to do a design, and now they've given me a specification and saying design to this. And I don't know how they've got there. And I don't know what they're trying to naturally achieve from it. I've got lots of questions about it, which I'm going to come back to. But first of all, I want to try and understand what this is saying, and what does it mean. Now, one of the things that we see on here, and a lot of the thing that stands out to me when I look at a document like that, is there's a lot of dBm values on there. Okay, we've got things like a minimum signal strength of minus 65 dBm, minimum signal noise of minus 25, secondary AP coverage has to be at least minus 75 dBm, channel overlap should be no greater than 2 channels at minus 80. These are all signal strength measurements. So I think if we're going to understand something like this and understand maybe why I have a problem with things like this, we need to understand signal strength to begin with. So I just want to spend a little bit of time, and we'll come back to this in a second, just thinking about signal strength and what signal strength is. In Wi-Fi systems, we typically measure signal strength in one of 4 ways. We have milliwatts, which is an absolute measure of signal. It's the amount of energy that's actually present. We have dBm, which is a logarithmic measurement of signal strength, and we can convert dBm to milliwatts. I'm sure that everybody knows that. We also have RSSI, and RSSI is a mechanism by which RF energy is measured by the circuitry on a wireless NIC. And this is actually the one I think is important, because this is the one how generally when we're talking about measuring signal strength, we're using wireless NICs, whether it's a NIC in our survey software or on another type of survey device, we're often measuring it using a wireless NIC. So what is RSSI? Well, it's an arbitrary integer between 0 and RSSI max. What is RSSI max? Well, it's the number of signal levels which a particular vendor or chipset can measure. Okay? So the other measurement, we'll come back to RSSI in a minute, but the other measurement is percentage. You'll see it, won't you, on some software it says 80% signal strength, 50% signal strength, 20% signal strength, whatever that means. Well, what is percentage? Percentage is an actual representation of the RSSI value. It's the RSSI value divided by the RSSI max multiplied by 100. So it's just basically a percentage of this RSSI value. So I just want to look at the RSSI value in a little bit more detail, as this is the way that our wireless cards measure signal strength. The quote on this slide is directly from the 802.11 standard. And it says this about RSSI. It says RSSI is an optional parameter that has a value of 0 to RSSI max. This parameter is a measure by the phi of the energy observed at the antenna used to receive the current PPDU. RSSI shall be measured between the beginning of the startup frame delimiter and the end of the physical convergence procedure header. I've put a little diagram there showing where we measure RSSI. If what I've just said there makes no sense to you at all, then I can highly recommend the Cybex CWAP study guide. I believe it was written by some quite good authors, so quick little plug there. But that's where we measure RSSI. The important bit of here, though, is what it says next. The next part of it says RSSI is intended to be a relative, is used in a relative manner. Absolute accuracy of the RSSI reading is not specified. So what we're saying there is there's no specified accuracy to the RSSI reading. And the standard isn't trying to stipulate any sort of relationship between RSSI and any particular measured milliwatt or dBm value. So vendors basically can choose their own level of accuracy for this and their own granularity as well. So if we look at the granularity, first of all, we've got, this is a sort of, think about how a vendor actually measures RSSI. It has each vendor, and I've got here vendor A, B, and C. These are actually taken from real vendors, but I decided not to put the vendor names up. Each vendor is going to pick a range, has a range of where it can measure signal. It can only measure signal levels at set levels. So vendor A, for example, can measure 101 different signal levels. It can from 0 to 100, so 100 is its RSSI max. Vendor B can measure, say, 60 different signal levels. It's actually 61 because it's from 0 to 60. Vendor C, 31 from 0 to 30. Now, obviously, there's a lot more dBm values than these 30 readings. So, but actually, some wireless NIC cards can only measure actually 30 different signal levels. And what the vendors then do is they generally have a table which maps RSSI values to dBm values. And this is how they can report dBm values. So in the example on my slide, the vendor A can actually report values from minus 10 dBm to minus 113. Vendor B, minus 35 to minus 95. Vendor C, minus 50 to minus 100. So there's a big variation between vendors on what signal levels, what their upper and lower limit is from what they can measure. And also within that, they can actually measure all the values. If you take vendor C there, for example, they can measure between minus 50 to minus 100. That's 50 dBm values, but they actually only measure signal at 30 different levels. So they're not even going to be able to report all of those levels between the two values. So we have a lot of variation between how different devices and different chipsets measure signal strength. And that's just how they measure it. There's also, as is fairly well known, they all have different receiver sensitivity as well. So they all will hear signals at different levels depending on the received circuitry. And I did a quick test as I was putting this presentation together. I had my Lenovo X220 laptop, and I took a Galaxy Note 3 and an iPhone 6 Plus, all at the same location, and measured the same access point. It was a dual radio access point with a 2.4 and 5 gig radio. So, as we can see at the very top one, the Lenovo X20 laptop, you would expect would probably be able to hear the signal with the strongest signal strength, and it did. It was minus 49 dBm in the 2.4 gig, and it could hear the 5 gigahertz signal at minus 52 dBm. We look at the Galaxy Note 3, and in the 2.4 gig band, it was hearing the AP from the same location at minus 66 dBm. That's a 17 dB difference from the Lenovo laptop. However, in the 5 gig band, it could hear it at minus 56 dBm, so only a 4 dB difference. And then we look at the iPhone, on the other hand, and in the 2.4 gig band, it was could hear it at minus 58 dBm, which is a 9 dB difference from the Lenovo laptop. And typically see that with iPhones, about a 10 dB difference. But then we look in the 5 gig band, and it was picking up the signal at minus 69. So that's a 17 dB difference. So different devices, and we know that, so they receive signal strengths at different values. However, it's not just each device that receives signal strengths differently. If you look at a device over time, you'll notice a big fluctuation in signal strength as well, just from the same device. So to do this, and the graph you're seeing on the chart was, I had a static AP and a static client. Neither of them were moving. And over a 2-minute period, the client measured the signal strength of every beacon it saw. It was a completely static environment, no one moving in between. AP and client completely in free range for each other, and these are the signal readings. And you can see there was the maximum signal strength it saw was minus 45, and the minimum was minus 63. So you've got a big variation in signal strength, even though the device wasn't even moving. Now, you can say there was an unusual peak there, but even if you discounted that, you've still got about 10 dB signal variation. Which is, again, I typically see that in a static environment. A client can see 10 dB of difference, that's 10 times the power, without even moving, due to things like multipath and various other factors. So,
do you think you would see that difference if you had cabled an AP radio directly to a client's radio? And I realize
if we'd cabled...
If you actually cabled the two radios together, what sort of...
What, with a piece of coax cable? I don't know. It's not something I've tested.
Primarily, though, this is multipath.
I think primarily it's multipath, yeah.
Okay, so if you cabled them, you'd expect it.
If you cable it, I would suspect, but it could also be you'll get some variation due to how because of what we just said about how they perceive signal strength, and there's an inaccuracy in how they measure signal strength for each client. So I still think you'll see a variation, but probably not as much. I think the fact that they depends on how they measure the bins will also you'll see a variation as well.
Have you tried that outdoor, where
I haven't tried it outdoor, no, but it's a good test. The test I did next, though, was I took the same client. It wasn't actually my phone; it was a laptop because I can measure the AP. But and then I went, I want to be in the same location, but we're not static, are we? Wi-Fi is all about mobility. So I stood on the same spot. I had my phone this way up. I had the device this way up, this way up. I turned around, sometimes my back to the AP, sometimes facing the AP. But the same physical location, I just moved about a lot. And that's this next one. So you can probably firstly tell when I was facing the AP and I wasn't, but you can see the difference now in signal strength between minus 38 dBm all the way down to minus 75 dBm. That is for the same physical location, the same device, just me moving the device around. So we put them on top of one another, and you can see just how much once we're moving, the signal variation varies even more. So back to the specification then. Signal strength is, to me, it has so many questions when people talk about measuring signal strength. We think about that static moving one. When with our site survey software, when we click and record the signal strength from its location, do we have our back to the AP when we do it? Are we facing it? Which orientation are our antennas in? I have too many question marks over signal strength. So some of the questions I might have with this specification, if I was going to talk to a customer about it, is, okay, you want a minimum signal strength of minus 65 as measured by what devices, in what orientation and position. And I know some people say, well, you pick your weakest device, but actually if my weakest device is my old iPhone 3G, which someone dropped in a pint of beer, and now unless you're a meter away from an AP, it doesn't connect to the Wi-Fi, then that's going to be a horrible Wi-Fi design if I design everything to that device. So I just think I'm not personally too sure what people mean when they say they want minus 65 everywhere. Okay, and I'll come a bit more back to that in a minute. What about minimum signal to noise? Fair enough, but how is the noise floor going to be measured? If it's going to be measured by a spectrum analyzer, I'll probably accept that. If you're going to measure it by a Wi-Fi card, then I can guarantee that if you think the signal levels vary a lot with Wi-Fi cards, you should see how they measure noise. It is even more inaccurate. So, providing we're measuring it, okay. What about secondary AP coverage? Should be at least minus 75 dBm according to this spec. Well, I would say we're sensible. So if you're looking at secondary coverage, the problem is if someone's given me this spec and say you have to meet its specification, that might not always be what the actual customer wants. So I had a university who gave me a similar specification once, and they wanted me to design for a new building going on campus. It was a theatre, which just didn't have Wi-Fi, and they wanted me to put it in. And backstage in the basement, behind massive thick concrete walls, they had a prop room, and they wanted Wi-Fi in it. And there would be the most maybe one or two people in that room. To meet their specification, it was completely isolated from all other Wi-Fi environments. I need to put 2 APs. They don't need 2 APs for 2 people. But if I'm going to meet their spec, I need 2 access points. So having this given to me at the input to a design site is actually limiting my design to make it optimized for that customer, especially if you're going to be held to it. What about co-channel overlap? The goal of every wireless LAN design should be as much as possible for that design to minimize co-channel interference. So for some scenarios, you're letting your designer off lightly if you say that they're allowed 2 channels. In some scenarios, you want to have none, ideally. You want to have just 1 AP on 1 channel. Given a high-density environment, it might be impractical to design it with only just 2, and that might not be the right solution. So having a blanket, this is a spec for all scenarios, isn't very good. And I don't think it's very helpful. Excuse me one moment. So I sometimes think if I've been asked to design a network and it starts off with a specification that the customer's given me, it's like they're putting me in handcuffs, putting a shackle around my leg, blindfolded me and saying, go and design a wireless network for us. And I wonder why we got into, why do we therefore so often specify networks this way?
It's our own damn fault, right? Because we went to customers and said, tell me your application. And we built networks to an application. And they said, I've got a new application. We say, oh, well, we didn't build it for that application. So it's the customers trying to preempt us.
It is.
Saying, we want to design for new applications without specifying the applications. Therefore, these are the only things that we can find that are measurable and tangible. It's our own fault.
I agree, and what you're saying now is it's our own fault, and it is, and I think to some extent why it's our own fault is to do with, and this is where I want to get into maybe how we validate networks, but the reason I'm saying I want to change the direction of your thinking is because I think it's like, let's say you wanted to go to downtown Phoenix, and you were traveling to downtown Phoenix, and you got on the freeway, and you realized after a few signs went by you were going the wrong way, and you went, gee, I'm going the wrong way, and you carried on going. And you know you're going the wrong way, and you tell the people in the back, we're going the wrong way. What do you need to do? You need to get off the freeway and start going the other way. And I think with Wi-Fi, what we've been doing is we've been saying for a while, we shouldn't be designing for coverage, we need to be designing for capacity. But we've been saying, hey, we need to design our wireless networks. We used to design for coverage, now we design for capacity, but we're still going this way. We need to design for capacity, but we're still going down, coming up with specifications which specify basically coverage. And why do we do that? And I think some of it is because of how we validate wireless networks. The survey says it's all green, so it's okay. If we validate networks based on signal strength, then actually we're going to specify them based on signal strength because that's what we can validate. So I'm going to specify something that I can validate, and then I can tell the customer I've done a good job, they're happy, it's all green, I'm going to get paid. So I want to suggest another way. And I'm going to, as I suggest another way, let's start off by just thinking about, again, hopefully stuff we all need to know, but what do we need to do when we specify a network? What's important? Well, the important things is, first of all, is the customer requirements. We need to know what the purpose of the wireless LAN is. We'll talk a little bit more about that in the next slide. But also, what's important to the end user? The end user wants to know, how can I get connectivity and do my apps work? Does my applications work? Can I do what I need to do? Does the end user care whether they've got mine at 65 or mine at 75 signal strength? They couldn't care less. They want to get connected and be able to do what they need to do. So if I design a network and I've got my customer going, well, you've got mine at 75 there, I'm not going to pay, I said mine at 65 everywhere. And I'm saying, yeah, but the users are happy, they can do what they need to do. It shouldn't matter what the signal strength is, what should matter is can the users achieve what they need to do where they are. I'll tell you, I've actually never designed for coverage. Even if we go back to the days before size survey tools, before we had things like our magnet and Akahow, when we used to have to do it manually, put an AP up on a stick with our building plan as a bit of paper, and we draw our coverage. You know how we used to do size surveys in those days? I used to have a tripod with a laptop at the bottom running an FTP server. And I had it going through a PoE battery to my AP, and I used to, with my client, as I walked away, I was running an FTP pull, and I was looking at my data rate and throughput I was getting. And when it went below the level my users required, that's where I drew my area of coverage on my map. Didn't look at signal strength at all. And it didn't actually occur to me to do so. It wasn't until we got site service that I started thinking, oh, should we look at signal strength? So let's talk a little bit, before I talk about maybe validation technique that I've started using, let's talk a bit about how we get the data we need in. We need the information gathering stage, and I'll say this in every class I ever teach, is the most important element of the design process. If you get the information gathering wrong, the rest of your design can end up being wrong. We need to know the purpose of the wireless network. What's it going to be used for? Is it being used just for BYOD? Is it being used for GETS? Do we need voice over Wi-Fi on it? Do we need to do real-time location? Because if we need to do real-time location, my access points are going to go in very different locations to what they are if I'm actually just doing it for data. Because I need to think about triangulation and location, and my access points are going to go more to the edge of the building than to the center. So I need to understand what the purpose is, what are the roaming requirements, why installing it. And sometimes the reason the wireless network is being installed when you actually probe the customer can be a really daft reason. You know, I've had before, well, we didn't really want Wi-Fi, but the CEO has got this iPad and he said he must use it at work. So we're having to install it. But what do I take away from that? It better be very good for the CEO. That's why we're designing the Wi-Fi. What areas need covering? Now, I think this is a great one when you talk about areas. You go to a customer and say, what areas do you want your Wi-Fi to work in? And I can virtually guarantee they'll come back and go, oh, everywhere. You go, okay, you want it everywhere, that's fine. So you want it in the plant rooms, do you? Do you want it in the toilets? Do you want it on the stairways? Do you want it in the lift? We can do your Wi-Fi in the lift if you want, but, you know, you're going to need more APs. Do you want it in the perimeter of your building, in the smoking shelter? What does everywhere mean? And very often, when she starts asking those questions, they'll say, oh, I don't know. So that's why knowing the purpose can help you define with them what areas. You know, if they want to do VoIP, then probably having coverage on the stairs is important because they may want people expect to be able to walk with a phone and walk downstairs. If they're not, you maybe don't need them in every staircase. If it's for a hospital and they've got, say, RFID tags with panic buttons on, maybe it's in a mental hospital where the nurses may get attacked and they can press a button, then they really do need coverage everywhere, or at least everywhere the nurses go. If they go outside for a cigarette and they get attacked, you better make sure that Wi-Fi works when they press a button, because it's going to locate the nurse and send security there to them. So understanding that purpose can then help us to start to define what the areas are. And we need to define those really well. And as we're understanding the areas, very often, things like our RF specification that we've had, you'll want different specifications for each area. Not all areas are going to be the same. You know, electrified could be a high-density area, but then you've got in the same building a corridor where you've just got offices for the lecturers of the university and the professors. Is going to be a very different requirement than a high-density sort of lecture theatre where you've got 6,600 students all wanting to connect. So we need to define our areas carefully. For each area, we then want to ask what will be the maximum number of simultaneous users connecting in that area. You know, worst case scenario, how many people could be trying to connect in this area? And again, you need to ask the right questions because you're not going to get that answer. They're not just going to come and go, oh yeah, it's 405 in this area, 20 in this one. They probably don't know, so you need to probe a little bit about how it's used. If you know you've got an office area with over 100 people spread across it, you can nicely cover that with however many APs you decide. But actually, once every 6 months, they all come together to a meeting room in the corner for a company meeting. Now I've got 100 people in one room, and we need to know about those exceptions that happen so that we can define the areas. And then the hardest question that your customers will be able to answer, and again you'll have to help them answer, is for each user, what data rate do they require? I've not had a customer yet who's gone, oh yeah, each of my users require 1.2 meg each. They won't be able to answer that question. So again, we need to know, and this is what really key when we're validating it, is well, what applications are they going to be using? What do you expect them to be doing? Are they running any bespoke applications? Is it just BYOD, in which case the more Wi-Fi network designs you've done, you can categorize BYOD activity in certain ways. There's been a few presentations this week which the statistics they've put up about which were the most hit websites, completely consistent with what I've seen in many different networks I've utilized. You've got the same sort of traffic patterns that exist when you get high density sort of BYOD networks. So we need to start to try and categorize things. It might be that you have to go and do some protocol traces. So if a school says, well, typically in a classroom, the teacher will say to the 40 students there, okay, I'd like everyone to go to www.youtube.com and all hit YouTube at the same time. You need to know what a typical YouTube video is going to take up. You can, if you don't know, try it out, take some packet captures, do some measurements. It's really, it's going to be, you're going to need to work. If it's a finance system which has a bespoke finance application that they can only use in Wired, say, well, can we take some captures and have a look what a typical transaction takes up? So you need to build up a database of what different applications use so that you can start to model what the actual throughput people are going to need. And other things you're going to be getting, Joe, in this sort of information gathering things is building plans, wall types, wall attenuation values as well. I'm very big in when I first have a customer meeting, I walk around the building and I measure the attenuation of all the wall types, or at least 2 or 3 of every type of wall. Because for my designs, I want to know exactly what the attenuation is of the wall. I don't like using the built-in values that are in some of these planning tools. I like to actually I can get a predictive survey to about 95% accurate if I'm taking real values and modeling the building correctly. But it takes time. And we shouldn't shy away from the need of time. So that's the sort of information I want, and that's going to lead me to define a network. It might be, and not always, it might be that this may lead you to come up with a guideline sort of our specification, a bit like we've seen. I would say if you're doing that, it's probably going to be different per area. So as I say, in a high-density lecture theatre, that's going to be different to maybe a teaching room, which again might be different to, some staff offices. So you need to be very willing to, if you're going to start to try and convert it into sort of signal strength, you come up with correct specifications per area. Do you have a few warnings I would give with this is just because you can specify something doesn't mean you can build it. You might say, and I had this very recently from another university I was in, that they had these big teaching rooms, and there was like, I'm sorry about the microphone issues. I'll try and bend it in a bit. Okay, hopefully not. Hopefully this is going to be a bit better. They had, say, 4 or 5, they had, I think, 3 rooms next to each other. All could take 300 students, okay? And then the other side of the corridor, another 3. So in a fairly close area, 6 rooms, 300 students each. And they said, yeah, we want all students to be able to get wired equivalent connections simultaneously in all rooms. Or all potentially streaming high-definition video. They can specify that. They even did a calculation in this document they gave me, specification document, that when they say wired equivalent privacy, that means per the APs they were using, they had calculated, or not even me, and it was reasonably accurate. That would mean they could have no more than 6 users per radio, 6 devices associated per radio. So you just do a calculation of that number of students of how many channels you need, and we don't have enough. There is only so much capacity in the air. And you can go above that. You've got so many channels. Each channel can give you so much capacity. You can make more airspace. So just because, be wary of people asking you for things which you can't build. Because you're just going to. The other thing is, be wary of people coming up with the wrong specification. So, and it probably was the case there as well, but come up with something that isn't actually realistic to what they actually need, and by which you'll get a design that doesn't really match what they need. I was asked to do a conference facility. It was a room similar to this in size, but they had 800. They were going to have 800 people in it, in a room similar to this size, literally chair next to chair, in raked seating, coming all the way to a stage, about this size as well, the stage. 800 people. And the company who asked me to do this for them had actually, it was actually a US-based company, and it was a UK office of theirs, and their Wi-Fi guys in the States had given them a design, and the way they had worked out the design was, they had said, well, there's 800 people, we're going to work with an average of 1.5 devices per user, so we've got, so we know, based upon that, we need about 1,400 devices, all connecting simultaneously. And they'd done some maps and worked out they needed, I think they'd come up with, I can't remember now, something like 35 access points for that room. And they had these Cisco high-density antennas pointing straight down. They had like one here, one here, one here, one here, in an entire grid. Luckily, I was able to tell them that that wasn't actually going to work very well, because they had way too many channels. One AP would have covered the entire room from a coverage point of view. So put in 35 APs, all with both 2.4 and 5 gig radios turned on, was going to be a nightmare. But you know, the main thing they'd got wrong was there was never going to be 1,200 devices all simultaneously communicating. So their specification was wrong, therefore the design was wrong. You know, at conferences, people are hopefully mainly listening to the person speaking. You definitely don't have half of the people with 2 devices out communicating at the same time simultaneously, and the other people all with 1 device out. And even at the break time, not everyone goes for the phones at the same time and goes, download my email at the exact same time. Some people chat first, some people. So when you monitor these environments, the requirements are much, much lower than what they actually needed. So part of my job actually was to help them redefine what their requirements were before I could design them a sensible network. Which we did, and the conference went really well. So, how many APs? I slightly overcooked. I actually put 15 APs in. I had, but most of those were on, all 15 was on separate 5 gig channel, and I only had 3 APs on 2.4 gig channels. Well, I actually had 4, but because I'm in Europe and I can have a 4-channel plan. But that's another story and maybe another debate for another day. So we won't talk about that now. So you need to be wary of these unrealistic requirements as well. So if we're going to specify a network in terms of a number of users requiring a certain throughput and certain applications, how do we validate that? Now, I'm going to tell you the way I've started doing it and doing some experiments with. I'm not saying this is the only way, and I'm open for people to to be other softwares. The software the system we've been using is IX Chariot. So I'm sure it's the only. I think at the moment it's the only way I found of actually doing this really well. But there could be other ways of doing it. So I'm not saying it's the only way, but I just want to go through a little bit what we're doing. I'll try and show you the interface to IX Chariot. Sorry. So it's IX Chariot by Ixia. I'll show you the interface. I'll show you though initially just some screenshots of some of the things that you can see with it. So this was just me messing around in my lab, but I wanted to look at, so let's say we need to support a certain number of voice calls through our wireless network. And I ran some IS-Chariot tests. So one thing you can do with IS-Chariot, you have you install basically a client on endpoints, and you can install them on iPhones, iPads, Android devices, Windows machines, so a whole host of different devices. And then you can program up some tests based upon different traffic patterns you want to run across the network, and it will try and run them for you. So it basically simulates and generates traffic. So my idea is, let's say we've got an area where, let's say a room like this, and we know we need to support certain types of traffic in it. And we know we need to support a certain number of single spatial devices, a certain number of two spatial devices. We've talked about what clients we need. How can we validate that? Well, my way would be, obviously, if there's 800 devices, we're not going to take 800 devices and put them all in a room, because I don't have 800 devices. But what I can probably find is a sample of some of the different devices. So maybe if I can have 5, maybe I can have 10 single spatial stream devices and 2 or 3 two spatial stream devices, or whatever the ratio actually is going to be, and I'll get each device to simulate multiple devices. So I've got one device over here simulating 20 devices, I've got another device over there simulating 20 devices, and I can actually make up that count. Because don't forget, Wi-Fi, especially from one location, is half duplex. Only one device is going to transmit at any one time. So why not simulate multiple devices based upon one device? But then you want to have devices from different locations as well. And we did, this was just a test just with just two devices. And the devices were just transmitting, they were each simulating 5 voice calls each. Okay, so I had 2 devices in different locations, each simulating 5 voice calls. So it's basically like simulating 10 voice sessions over the wireless. And you'll see actually from this, actually when I was simulating 5 each, so 10 in total, things actually worked quite well. We've got a nice steady pattern. You're actually pretty much seeing there the 20 millisecond voice packets being delivered and received, hence you've got an up and down scenario in the throughput. I want to show you what happened when I upped that to 10 voice calls per device. Things started to not be quite so consistent. And we started getting, I don't know how easy you can see actually there, but in the middle of here it tells me things like the amount of bytes lost, the jitter, the one-way delay, and the number of errors received as well. So from when we did 5, it also gives me MOT scores as well, or it can do. So we can see that if we look at the by slots when we do 5 calls compared to 20, it significantly went up. We were dropping a lot more packets, and you can say the system wasn't really delivering and working with 10. Just out of interest, I did a test and I made each device simulate 20 voice calls, and you can see how the traffic now completely drops off at one point, and we start getting lots and lots of packets lost, and we get much worse one-way delay and one-way jitter. So you can start to, with it, sort of look at how much you can load up a system, where it's going to break, and actually validate, can you support the number of devices or the number of calls you actually need on a system? Because you're actually trying the actual traffic, which you've found from your information gathering out, you know that what traffic they're expecting, you can actually add that traffic onto the devices. Yes, so you can put the endpoints at multiple places. So they're not in the same places, these endpoints. So I've got 2 endpoints, each doing 5 voice calls, but I can put them in different places around the hospital.
You've got a large facility, so when you're doing closed survey for SQL, that's easy.
Yeah. Yeah, and if you're looking at how sort of Kerr-channel interference might affect it, if you've got two APs on the same channel, and you want to look at what they actually put some devices near one of the APs, some near associated to the other, and run tests at the same time. You can actually test that. So if I'll give you, I have actually got it. We've got it running the RIX Chariot server running on in our cloud, so it's accessible from the network. So I'll show you what the interface looks like, and you know, I've got an endpoint running on my phone here. So let me just switch out to. This is the interface that we've got here. If I was to create a new test, as it were, I've actually got. Let me just start Chariot on its endpoint. I've also stuck it on the tablet that we got in our packs. So I've got iOS Chariot running on these two devices. Also, we can put these devices in different locations. They could be in different rooms, different places within the building. And you can basically run a test on them both. I've also got, for this test to work, you want to have something you're running your test back to. I normally take a laptop out with me and try and get it on the wired network. But for this example, it's going to be my laptop, which is also on the wireless here, because I haven't actually got a connection onto the wired network. But if what I can do is there's different types of things I can add in. So I can add in what's called a flow mix, and you'll see here, although you can customize this, there's a lot of library things that are already built in. So there's TCP, low performance, baseline performance. There's information on what each of these are, and you can change the settings. And this is where I can do things like, okay, I want to select a G711 voice conversation. I can just let it is a little bit slow over the Wi-Fi. I can say how many users I want that to be for. So I could say I want it to be 5 users, and I can even specify a QoS level as well. So I might say I want it to go out marked with voice QoS. As well. So that doesn't seem to have updated. Let me just try and do that again. There we go. So I've even marked it as being voice priority as well. So we can specify, and I might say, okay, I'm going to say Bob here, that's my iPhone. I don't know why I call my iPhone Bob, I just do. And I'm going to have Bob sending that out, and it's going to go to my laptop here. So we'll just move that over there. It's that easy to sort of set per test. I can have multiple devices doing the same test if I want. So you can see it says one source. I could have different endpoints also performing the same test. Or I could say I want a mixture. So I want my iPhones. I've maybe got several iPhones doing the voice call, or my voice phones, and then I want my Android tablets maybe doing a bit of a mix of different applications. So I can add an application mix into here. And from here, I might say, well, we're going to do some bandwidth HTTP, and we're going to, let's just add a couple of other applications. We're going to have some Facebook usage, and what else might be sort of common? Let's say we've got some Google Mail, let's say. But you can start to build up a different application. Say maybe I'm going to have 20, say, users doing this, and I know that the majority of those is going to be doing, say, 50% is going to be doing Facebook. Hoping it'll let me actually change that to 50 this time. Yeah, 50. So I've got 50, 25, and 25 as my mix. So 5 users are going to be doing bandwidth HTTP, 5 sessions are going to be doing Google Mail, and I've got 14 here doing Facebook. I then specify how long I want my test to run. We'll just put 1 minute for this example. And then we literally click Start Test. And what this will do is, it's going to now give me an error. What's that going to be? Oh, I haven't put a source. I haven't specified any devices for that second test. That's why. So it's going to be, come to my laptop again, and this time I'm going to pick the Android client as Samson, as the person who's going to do that one. I can then start the test, hopefully. And what it'll do is it'll now send that config and that traffic it wants these devices to generate to the devices, and it'll also tell it where it's sending it. So that's what it's doing. At this point, it just sends the config to them. Yeah.
In the past, solutions like this have been prohibitively expensive, such that you can't justify the ROI. Customers look at you and they say, okay, the incremental cost to doing this, because you're spreading this out over multiple customers, it simply isn't worth the time, energy, effort, and ultimately cost. Can you give us some insight into how you justify the ROI from a corporate perspective of purchasing a product?
So the question is that products like this tend to be extremely expensive, and it is. So how do I justify the cost against the services I'm offering? Well, I would say we shouldn't be. First of all, you're not going to make it back in one survey. This is something but I think over like 4 or 5 surveys, it'll start to pay for itself. That would be, but I guess that's a little bit different on what you charge for your services. I'm a big believer in that we shouldn't make our services cheap. I don't like doing people when they say we do site surveys for free, because it unvalues the expertise. Everyone in this room has expertise, and you should be paid for that expertise and that knowledge. And if you've set the thinking, well, I'll do the survey for free because I made the money on the APs, I would rather sell the APs at the cost I buy them to the customer and charge more for my services so that they know where the value is. Sure, the value's in your expertise, but I think if you're charging a reasonable amount for professional services, and you should charge for doing the validation. You should charge for the validation, and I think if you're charging for the validation, I think you can make the money back in, as I say, 4 or 5.
Sure, but if you've got 1 or 2 customers that say, I need to test, my design requirements are 100 clients.
Yeah.
And you have to pay for 100 client licenses of Chariot, and then you have to pay annual support.
Okay.
Right? You get, I'm not saying every bar is like this or every even small customers like this, right? But if you've got one, that whale of customer, you're never going to be able to make that back because it's just so out of whack with.
So you're saying if you've got one person who has decided for testing 100, well, the way it works is you get like 50. I think the minimum you can buy is 50 client license. So I think it's 50 device one is what we've got a license for. So we've got 50. So we can't do more than 50. But we haven't got actually 50 wireless clients. But I would say you don't need to. So if they want you to test 100, can you not have 10 devices each simulating 10 endpoints, each simulating 10 clients? Is that not good enough? That's what I'd argue, because then you can have them at different locations, so you get the sort of spatial diversity of your clients, but you still, within a client is covering an area of clients. That's my approach to it anyway. So I would never go out to, I reckon with 10 or a few clients, I reckon with about 10 different clients, you can cover most areas. You may need to do a test in one area of the building, move your 10 clients to another and do another test.
Right, but you're backpedaling some on your original message, which is get a clear definition up front of what the client requirements are. Let's say it's an auditorium.
Yeah, but if it's not...
I've got to support 150 clients.
You do, but I can simulate 150 clients with less endpoints. That's what I'm saying.
And
I don't need 100 endpoints to simulate 100 clients.
No, I mean, I'm asking you, like, is that good enough?
I believe so, yeah. But don't do it on one. And this is what I'm really keen. Don't try and simulate 100 people on one because they're in the one location. They're all going to go to the same AP. You need to spread your clients out and then simulate your 100. So you need to simulate. I reckon if you can simulate 100 to every 10 endpoints roughly. So if they wanted 200, I'd probably want 20 endpoints. That would be my rough gauge.
So the problem that I've had with simulating endpoints in the past has been that it can't accurately simulate RF contention still. So you give the example earlier of the voice calls.
Yeah.
And I have tested this with actual voice clients versus simulated voice clients. And due to contention window sizing and backoffs and things like that, the simulated results don't come close to what the actual voice endpoints when you do a real test with real endpoints. Because it's a distributed contention medium, right? If you're simulating it on one device, you're missing part of that RF contention that they go through. And that can be a huge factor, especially on, like, say, voice priority, where the contention window is very small.
Yeah, I would agree with you, and that's why I think I like trying to have as many endpoints as possible, but you can't have 100 endpoints. So you've got to compromise somewhere. So my aim is always to have, the number of devices I'm simulating per device to be minimum, to be as low as possible. If I can, have 50 endpoints, I'll do it. But with the best will in the world, I guess this is a compromise really. But I definitely won't have one endpoint doing everything. I like to try and have as many endpoints as I can, but I found it to be it's not perfect, but it's reasonably. I found it good enough, and I've done a few large sort of lecture theatres with, sort of 900 people, and sort of simulated it relatively enough, and then I've been on the event itself and done captures from the event itself, and found that it's performed relatively similar. Relatively simple. I've only used the Ixia system to do this simulation though, so I can't say for like other methods. But and anyway, that was my. I just hope that would maybe get people to maybe think in a different way. I hope it was helpful. Thank you very much.